Book 1, Chapter 3 of the Mind and the Brain. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. The Mind and the Brain by Alfred Binet, F. Legge, editor. Book 1, The Definition of Matter. Chapter 3, The Mechanical Theories of Matter are Only Symbols. If we keep firmly in mind the preceding conclusion, a conclusion which is neither exclusively my own nor very new, we shall find a certain satisfaction in watching the discussions of physicists on the essence of matter, on the nature of force and of energy, and on the relations of ponderable and imponderable matter. We all know how hot is the fight raging on this question. At the present time it is increasing in intensity in consequence of the disturbance imported into existing theories by the new discoveries of radioactivity. Note: I would draw attention to a recent volume by Gustave Le Bon on Évolution de la Matière, a work full of original and bold ideas. We psychologists can look on very calmly at these discussions, with that selfish pleasure we unavowedly feel when we see people fighting while ourselves safe from knocks. We have in fact the feeling that, come what may from the discussions on the essence of matter, there can be no going beyond the truth that matter is an excitant of our nervous system, and is only known in connection with the perception we have of this last. If we open a work on physics or physiology, we shall note with astonishment how the above considerations are misunderstood. Observers of nature who seek, and rightly, to give the maximum of exactness to their observations, show that they are obsessed by one constant prejudice: they mistrust sensation. A great part of their efforts consists, by what they say, in reducing the rôle of sensation to its fitting part in science, and the invention of mechanical aids to observation is constantly held up as a means of remedying the imperfection of our senses. In physics, the thermometer replaces the sensation of heat that our skin, our hand, for example, experiences by the measurable elevation of a column of mercury, and the scale pan of a precise balance takes the place of the vague sensation of trifling weights. In physiology, a registering apparatus replaces the sensation of the pulse, which the doctor feels with the end of his forefinger, by a line of paper traced with indelible ink, by which the duration and the intensity, as well as the varied combinations of these two elements, can be measured line by line. Learned men who pride themselves on their philosophical attainments vaunt in very eloquent words the superiority of the physical instrument over mere sensation. Evidently, however, the earnestness of this eulogy leads them astray. The most perfect registering apparatus must, in the long run, after its most scientific operations, address itself to our senses and produce in us some small sensation. The reading of the height reached by the column of mercury in a thermometer when heated is accomplished by a visual sensation, and it is by the sight that the movements of the balance are controlled, and that the traces of the sphygmograph are analyzed. We may readily admit to physicists and physiologists all the advantages of these apparatus. This is not the question. It simply proves that there are sensations and sensations, and that certain of these are better and more precise than others. The visual sensation of relation in space seems to be par excellence the scientific sensation which it is sought to substitute for all the rest. But after all, it is but a sensation. Let us recognize that there is, in all this contempt on the part of physicists for sensation, only differences in language, and that a paraphrase would suffice to correct them without leaving any trace. Be it so. But something graver remains. When one is convinced that our knowledge of the outer world is limited to sensations, we can no longer understand how it is possible to give oneself up, as physicists do, to speculations upon the constitution of matter. Up to the present there have been three principal ways of explaining the physical phenomenon of the universe. The first, the most abstract, and the furthest from reality, is above all verbal. It consists in the use of formulas in which the quality of the phenomena is replaced by their magnitude, in which this magnitude, ascertained by the most precise processes of measurement, becomes the object of abstract reasoning which allows its modifications to be foreseen under given experimental conditions. This is pure mathematics, a formal science depending upon logic. Another conception, less restricted from the above, and of fairly recent date, consists in treating all manifestations of nature as forms of energy. This term, energy, has a very vague content. At the most, it expresses but two things. First, it is based on a faint recollection of muscular force, and it reminds one dimly of the sensation experienced when clenching the fists; and secondly, it betrays a kind of very natural respect for the forces of nature which, in all the images man has made of them, constantly appear superior to his own. We may say the energy of nature; we should never say, what would be experimentally correct, the weakness of nature. The word weakness we reserve for ourselves. Apart from these undecided suggestions, the term energy is quite the proper term to designate phenomena, the intimate nature of which we do not seek to penetrate, but of which we only wish to ascertain the laws and measure the degrees. A third conception, more imaginative and bolder than the others, is the mechanical or kinetic theory. This last absolutely desires that we should represent to ourselves, that we should imagine, how phenomena really take place, and in seeking for the property of nature the most clearly perceived, the easiest to define and analyze, the most apt to lend itself to measurement and calculation, it has chosen motion. Consequently, all the properties of matter have been reduced to this one, and in spite of the apparent contradiction of our senses, it has been supposed that the most varied phenomena are produced, in the last resort, by the displacement of material particles. Thus sound, light, heat, electricity, and even the nervous influx would be due to vibratory movements, varying only by their direction and their periods, and all nature is thus explained as a problem of animated geometry. This last theory, which has proved very fertile in explanations of most delicate phenomena of sound and light, has so strongly impressed many minds that it has led them to declare that the explanation of phenomena by the laws of mechanics alone has the character of a scientific explanation. Even recently, it seemed heresy to combat these ideas. Still more recently, however, a revulsion of opinion has taken place. Against the physicists, the mathematicians in particular have risen up, and taking their stance on science, have demonstrated that all the mechanisms invented have crowds of defects. First, in each particular case, there is such a complication that that which is defined is much more simple than the definition; then there is such a want of unity that such special mechanisms adapted to each phenomenal detail have to be imagined; and lastly, most serious argument of all, so much comprehensiveness and suppleness is employed, that no experimental law is found which cannot be understood mechanically, and no fact of observation which shows an error in the mechanical explanation, a sure proof that this mode of explanation has no meaning. My way of combating the mechanical theory starts from a totally different point of view. Psychology has every right to say a few words here, as upon the value of every kind of scientific theory, for it is acquainted with the nature of the mental needs of which these theories are the expression, and which these theories seek to satisfy. It has not yet been sufficiently noticed that psychology does not allow itself to be confined, like physics or sociology, within the logical table of human knowledge, for it has, by a unique privilege, a right of supervision over the other sciences. We shall see that the psychological discussion of mechanics has a wider range than that of the mathematicians. Since our cognition cannot go beyond sensation, shall we first recall what meaning can be given to an explanation of the inmost nature of matter? It can only be an artifice, a symbol, or a process convenient for classification in order to combine the very different qualities of things in one unifying synthesis; a process having nearly the same theoretical value as a memoria technica, which, by substituting letters for figures, helps us to retain the latter in our minds. This does not mean that figures are, in fact, letters, but it is a conventional substitution which has a practical advantage. What memoria technica is to the ordinary memory, the theory of mechanics should be for our needed unification. Unfortunately, this is not so. The excuse we are trying to make for the mechanicians is illusory. There is no mistaking their ambition, notwithstanding the prudence of some, and the equivocations in which others have rejoiced; they have drawn their definition in the absolute and not in the relative. To take their conceptions literally, they have thought the movement of matter to be something existing outside our eye, our hands, and our sense; in a word, something noumenal, as Kant would have said. The proof that this is their real idea is that movement is presented to us as the true outer and explanatory cause of our sensations, the external excitement to our nerves. The most elementary works on physics are impregnated with this disconcerting conception. If we open a description of acoustics, we read that sound and noise are subjective states which have no reality outside our auditory apparatus, that they are sensations produced by an external cause, which is the vibratory movement of sonorous bodies. Whence the conclusion that this vibratory movement is not itself a sensation. Or, shall we take another proof, still more convincing? This is the vibratory and silent movement which is invoked by physicists to explain the peculiarities of subjective sensation, so that the interferences, the pulsations of sound, and, in fine, the whole physiology of the ear, is treated as a problem in kinematics, and is explained by the composition of movements. What kind of reality do physicists then allow to the displacements of matter? Where do they place them, since they recognize otherwise that the essence of matter is unknown to us? Are we to suppose that, outside the world of noumena, outside the world of phenomena and sensations, there exists a third world, an intermediary between the two former, the world of atoms and that of mechanics? A short examination will, moreover, suffice to show of what this mechanical model is formed, which is presented to us as constituting the essence of matter. This can be nothing else than the sensations, since we are incapable of perceiving or imagining anything else. It is the sensations of sight, of touch, and even of the muscular sense. Motion is a fact seen by the eye, felt by the hand. It enters into us by the perception we have of the solid masses visible to the naked eye, which exist in our field of observation, of their movements and their equilibrium, and the displacement we ourselves effect with our bodies. Here is the sensory origin, very humble and very gross, of all the mechanics of the atoms. Here is the stuff of which our lofty conception is formed. Our mind can, it is true, by a work of purification, strip movement of most of its concrete qualities, separate it even from the perception of the object in motion, and make of it something or other ideal and diagrammatic, but there will still remain a residuum of visual, tactile, and muscular sensations, and consequently it is still nothing else than a subjective state, bound to the structure of our organs. We are, for the rest, so wrapped up in sensations that none of our boldest conceptions can break through the circle. But it is not the notion of movement alone that proceeds from sensation. There is also that of exteriority, of space, of position, and, by opposition, that of external or psychological events. Without declaring it to be certain, I will remind you that it is infinitely probable that these notions are derived from our muscular experience. Free motion, arrested motion, the effort, the speed, and the direction of motion, such are the sensorial elements which, in all probability, constitute the foundation of our ideas on space and its properties. And those are so many subjective notions which we have no right to treat as objects belonging to the outer world. What is more remarkable, also, is that even the ideas of object, of body, and of matter are derived from visual and tactile sensations which have been illegitimately set up as entities. We have come, in fact, to consider matter as being separate from sensations, superior to our sensations, distinct from the properties which enable us to know it, and binding together these properties, as it were, in a sheaf. Here again is a conception at the base of visualization and muscularization. It consists in referring to the visual and other sensations, raised for the occasion to the dignity of external and permanent causes. The other sensations which are considered as the effects of the first, named upon our organs of sense. It demands a great effort to clear our minds of these familiar conceptions, which, it is plain, are nothing but naive realism. Yes, the mechanical conception of the universe is nothing but naive realism. To recapitulate our idea, and to make it more plain by an illustration, here is a tuning fork on the table before me. With a vigorous stroke of the bow I set it vibrating. The two prongs separate, oscillate rapidly, and a sound of a certain tone is heard. I connect this tuning fork by means of electric wires with a Dupre recording apparatus which records the vibrations on the blackened surface of a revolving cylinder, and we can thus, by examination of the trace made under our eyes, ascertain all the details of the movement which animates it. We see, parallel to each other, two different orders of phenomena, the visual phenomena which show us that the tuning fork is vibrating, and the auditory phenomena which convey to us the fact that it is making a sound. The physicist, asked for an explanation of all this, will answer, it is the vibration of the tuning fork which, transmitted by the air, is carried to our auditory apparatus, causes a vibration in the tympanum, the movements of which are communicated to the small bones of the middle ear, thence, abridging details, to the terminations of the auditory nerve, and so produces in us the subjective sensation of sound. Well, in so saying, the physicist commits an error of interpretation. Outside our ears there exists something we do not know which excites them. This something cannot be the vibratory movement of the tuning fork, for this vibratory movement which we can see is likewise a subjective sensation. It no more exists outside our sight than sound exists outside our ears. In any case, it is as absurd to explain a sensation of sound by one of sight as a sensation of sight by one of sound. One would be neither further from nor nearer to the truth if we answered that physicist as follows. You give the preponderance to your eye. I myself give it to my ear. This tuning fork appears to you to vibrate. Wrong. This is how the thing occurs. This tuning fork produces a sound which, by exciting our retina, gives us a sense of movement. This visual sensation of vibration is purely a subjective one. The external cause of the phenomenon is the sound. The outer world is a concert of sounds which rises in the immensity of space. Matter is noise, and nothingness is silence. This theory of the above experiment is not absurd, but as a matter of fact it is probable that no one would or could accept it, except verbally for amusement, as a challenge, or for the pleasure of talking metaphysics. The reason is that all our evolution, for causes which would take too long to detail, has established the hegemony of certain of our senses over the others. We have, above all, become visual and manual beings. It is the eye and the hand which gives us the perceptions of the outer world of which we almost exclusively make use in our sciences, and we are now almost incapable of representing to ourselves the foundation of phenomena otherwise than by the means of these organs. Thus, all the preceding experiment from the stroke of the bow to the final noise presents itself to us in visual terms, and further, these terms are not confined to a series of detached sensations. Visual sensation combines with the tactile and muscular sensations, and forms sensorial constructions which succeed each other, continue, and arrange themselves logically. In lieu of sensations, there are objects and relations of space between these objects, and the actions which connect them, and the phenomena which pass from one to the other. All that is only sensation, if you will, but merely as the agglutinated molecules of cement and of stone are a palace. Thus the whole series of visual events which compose our experiment with the tuning fork can be coherently explained. One understands that it is the movement of my hand equipped with the bow which is communicated to the tuning fork. One understands that this movement passing into the fork has changed its form and rhythm, that the waves produced by the fork transmit themselves, by the oscillations of the air molecules, to our tympanum, and so on. There is in all this series of experiments an admirable continuity which fully satisfies our minds. However much we might be convinced by the theoretical reasons given above, that we have quite as much right to represent the same series of events in an auditory form, we should be incapable of realizing that form to ourselves. What would be the structure of the ear to any one who only knew it through the sense of hearing? What would become of the tympanum, the small bones, the cochlea, and the terminations of the acoustic nerve, if it were only permitted to represent them in the language of sound? It is very difficult to imagine. Since, however, we are theorizing, let us not be stopped by a few difficulties of comprehension. Perhaps a little training might enable us to overcome them. Perhaps musicians, who discern as much reality in what one hears as in what one sees, would be more apt than other folk to understand the necessary transposition. Some of them, in their autobiographies, have made, by the way, very suggestive remarks on the importance they attribute to sound, and, moreover, the musical world, with its notes, its intervals, and its orchestration, lives and develops in a manner totally independent of vibration. Perhaps we can here quote one or two examples which might give us a lead. To measure the length of a body instead of applying to it a yard wand, one might listen to its sound, for the pitch of sound given by two chords allows us to deduce their difference of length, and even the absolute length of each. The chemical composition of a body might be noted by its electrical resistance, and the latter verified by the telephone, that is to say, by the ear. Or, to take a more subtle example, we might make calculations with sounds of which we have studied the harmonic relations, as we do nowadays with figures. A sum in rule of 3 might even be solved sonorously, for, given 3 sounds, the ear can find a fourth which should have the same relation to the third as the second to the first. Every musical ear performs this operation easily. Now this fourth sound, what else is it but the fourth term in a rule of three? And by taking into consideration the number of its vibrations, a numerical solution would be found to the problem. This novel form of calculating machine might serve to fix the price of woolen stuffs, to calculate brokerages and percentages, and the solution would be obtained without the aid of figures, without calculation, without visualization, and by the ear alone. By following up this idea, also, we might go a little further. We might arrive at the conviction that our present science is human, petty, and contingent, that it is closely linked with the structure of our sensory organs, that this structure results from the evolution which fashioned these organs, that this evolution has been an accident of history, that in the future it may be different, and that, consequently, by the side or in the stead of our modern science, the work of our eyes and hands, and also of our words, there might have been constituted, there may still be constituted, sciences entirely and extraordinarily new, auditory, olfactory, and gustatory sciences, and even others derived from other kinds of sensations which we can neither foresee nor conceive because they are not, for the moment, differentiated in us. Outside the matter we know, a very special matter fashioned of vision and touch, there may exist other matter with totally different properties. But let us bring our dream to an end. The interest of our discussion does not lie in the hypothetical substitution of hearing or any other sense for sight. It lies in the complete suppression of all explanation of the noumenal object in terms borrowed from the language of sensation, and that is our last word. We must, by setting aside the mechanical theory, free ourselves from a too narrow conception of the constitution of matter, and this liberation will be to us a great advantage which we shall soon reap. We shall avoid the error of believing that mechanics is the only real thing, and that all that cannot be explained by mechanics must be incomprehensible. We shall then gain more liberty of mind for understanding what the union of the soul with the body may be. End of Book 1, Chapter 3.